Section 5.2 is talking about how to multiply decimals, the standard procedure, and other methods. So here we're looking at 0.23 times 1.7. So we first multiply as if decimal points were not there. So we ignore the decimal points. And then we're going to place the decimal point in the answer. So question A, how could a student determine where to put the decimal point if a student has forgotten the standard rule about adding the number of places behind the decimal points? So this is the standard procedure, but if a student forgot it, what are other alternatives? So what we can as a backup solution or alternative, we could use estimation to do it. Again, here you're not allowed to use the rule, which is stated here. So you have to use something different because assuming the student has forgotten the rule. So we're going to use the estimation. 0.23 is between 0 and 1. 1.7 is between 1 and 2. So when we multiply these two numbers, we're going to end up with multiplying the two lower bounds, which is 0, and multiply the two numbers in the middle, and multiply the two numbers, the upper bounds. 1 times 2 is 2. And so for these whole numbers, we use whole numbers for the lower bound and upper bound, and because it's easy to do multiplication between them. So 1 times 2 is 2, 0 times 1 is 0. But for the decimals, because it's not easy to see what the answer is when we multiply them, so we could just keep them here without multiplying them out, because this would give us an idea how big the answer should be. So the answer, the product, should be between 0 and 2. Okay, so if we ignore the decimal point and multiply them out as whole numbers, like 17 times 23, and we end up with 391. And so we need to put the decimal point back such that we get an answer that is between 0 and 2. So notice that if we put decimal point here, it's still bigger than 2. So we have no choice but put a decimal point right here, and which is 0.391. Okay, in part B, explain why the rule of for placement of the decimal point in the multiplication division problems makes sense. So what is the logic behind adding the number of places behind the decimal points? Okay, so we in part A we used an estimation method. In part B, we want you to explain why we go back to the standard method, but why the standard method the procedure works. For example, when we multiply decimal points, we ignore the decimal point, and decimal numbers, we ignore the decimal points, and we multiply them like whole numbers. Why could we do that? And also, why we adding the decimal places to get 3 and could place it in the answer. And so here, there are different ways we can explain. So the easy one is to use convert them to fractions. 0.23, this 3 means hundredth. So we have 23 hundredths. 1.77 means tenths. So we have 17 tenths. And to use the multiplication rule of fractions, which is introduced in section 5.1. So we multiply straight across. We get 23 times 17. So the numerator of the fraction explains why the first step of the procedure works, because we are literally multiplying the numerators of these two fractions converted from the decimals. So that's the step 1. Ignore the decimal points, multiply them out like whole numbers. But we have to modify our answer. Once we get the answer, we have to divide them by 100 times 10. And so why do we put the decimal point? Why do we add the 2 decimal places and 1 decimal place, like here 2 decimal places, and here 1 place, and add them up to get 3 places and place it in the answer? So that's because 100 can be broken down as 10 times 10, and there's another 10 that comes from 1.7. So we have these 2 10s come from 0.23. And notice, because 3 means 3 tenths, so we have 2 300th, and 100th has 2 tenths in the denominator, because 100 can be broken down as 2 tenths. So that's why we can add. We are actually, how do we modify our whole number answer to get the answer for the decimals? And we're going to divide by 10 3 times. And each time we divide the answer by 10, we move the decimal point to the left 1 place. So if we divide 10 3 times, we have to move the decimal point to the left 3 times. So that's why we end up with the 0.391 if we use the standard procedure. And again, the number of tens we have is exactly the total number of decimal places, because 1/10 you have 7/10 you have a 10, and 2300th you have 2 tenths. So together we have 3 tenths, and that's the total number of place values. That total number of the places to the right of the decimal point. So that's why we can place the add the total number of places, and 2 here, 1 here, and a place in the final answer.